Good morning, students. Today's topic is oxoacids of phosphorus. Let us discuss one by one. First one is hypophosphorus acid. Hypophosphorus acid or phosphinic. Okay. Its formula is H3PO2. And here phosphorus is having the oxidation state +1. The number of bonds present are, it contains 1 POH, 2 PH and 1 P double bond. It can be prepared by the reaction between white phosphorus and alkali. White phosphorus and alkali. Now, second compound is orthophosphorus acid or phosphonic. Orthophosphorus acid or phosphonic. And its formula is H3PO3. Here phosphorus is having the oxidation state +3, okay, and it contains the number of bonds present 2 POH, 2 PH and 1 P double bond. Okay, sorry, 2 POH, 1 PH, 1 PH and 1 P double bond, and it can be prepared by the reaction between P2O3 and H2O. Now, third one is ortho, and the third one pyrophosphorus acid. Pyrophosphorus acid. Third one pyrophosphorus acid, and it is H4P2O5. Here the phosphorus is having the oxidation state +3 itself. Now it contains 2 POH, 2 PH and 2 P double bond. 2 POH, 2 PH and 2 P double bond O. Okay. How can we prepare? It can be prepared by the reaction between PCl3 and H3PO3. Okay. PCl3 and H3PO3. Now, hypophosphoric acid. Hypophosphoric acid, and its formula H4P2O6. H4P2O6. And here the phosphorus is having the oxidation state +4. Now the number of bonds present 4 POH, 4 POH. See the difference, 2 P double bond O, 2 P double bond O and 1 PP bond is there, 1 PP bond. Okay, is the difference. Now, how can we prepare? By the reaction between red phosphorus and alkali. Now, fifth one is orthophosphoric acid. Orthophosphoric acid. Orthophosphoric acid, and its formula H3PO4, and here the phosphorus is having the oxidation state +5 and it contains, see the difference, 3 POH and 1 P double bond O. 3 POH and 1 P double bond O. Okay. Now, how can we prepare? Reaction between P4O10 and H2O. Okay. Next compound, pyrophosphoric acid. Pyrophosphoric acid. Pyrophosphoric acid. Its formula is H4P2O7. Okay, and oxidation state of phosphorus +5. Now it contains 4 POH, 4 POH and 2 P double bond O, and it contains 1 POP bond. See the difference, POP bond. Okay. Now, How can we prepare? On heating phosphoric acid. It can be prepared by heating phosphoric acid. Phosphoric acid. Okay. Now, metaphosphoric acid. It exists in the polymeric form only. Metaphosphoric acid. Metaphosphoric acid. Its formula is H3PO3 thrice. HPO3, right? Or HPO3 thrice. HPO3 thrice. See the difference. It is the metaphosphoric acid is HPO3 thrice and it is having the oxidation state. Phosphorus is having the oxidation state +5 and it contains 3POH. 3POH. Now, 3PO bond is present. 3PO bond. Okay. From the structure, we can identify the structures. Okay. We will discuss after this. We will discuss different structures of the some of the compounds. 3POP bond. Okay. Metaphosphoric acid contains 3POH, 3P double bond O, and 3POP bonds. Now, how can we prepare? It can be prepared from phosphorus acid and bromine. Phosphorus acid plus bromine. Okay. This on heating in a sealed tube. Heating in a sealed tube, we will get polymeric form metaphosphoric acid. Now, let us discuss some structures. Okay. Structures of some oxoacid structures. First one, H3PO2. H3PO2 is hypophosphorus acid. Okay, hypophosphorus acid. And the structure, P double bond O, then 2 pH bonds are present and 1 POH. Now, second one is orthophosphorus acid, H3PO3, H3PO3 orthophosphorus acid. What is its formula? It contains P double bond O, 1 pH and 2 POH bond. Now, third one, orthophosphoric acid, H3PO4. Orthophosphoric acid. Orthophosphoric acid. Orthophosphoric acid. It contains 1 P double bond O and 3 POH bonds. Okay. Now, fourth one, pyrophosphoric acid. What is the formula for pyrophosphoric acid? H4P2O7. Pyrophosphoric acid. And it contains, the formula will be like this. 2P double bond O and it contains a POP bond. Okay. Now, see 4 OH, POH bond, 4 POH bond. Now, next one is metaphosphoric acid. First, HPO3 thrice. This is cyclotrimetaphosphoric acid. Trimetaphosphoric acid. Okay. Cyclotrimetaphosphoric acid. And the formula will be like this. Now, POP bond is there. Now, double bond O. Double bond O. Then OH bond. This will be the structure of cyclotrimetaphosphoric acid. Okay. Now, next last one is polymetaphosphoric acid, HPO3 N times polymetphosphoric acid. What is this formula? It's N times. Okay. So P double bond O, POP bond will be there. Okay. Now here OH and here OH and here double bond O. Okay. Again POP. Now double bond O, OH goes up. It's N times. Okay. So this will be the structure of polymetphosphoric acid. Now let us discuss some properties of these oxoacids. So oxoacids, we already seen that in oxoacids phosphorus is tetrahedrali surrounded by other atoms. Okay, tetrahedrali surrounded by other atoms. We already seen that. And it contains, what are the bonds present in them? They contain at least one P double bond O and one POH bond. It contains at least one P double bond O and one POH bond. Okay. This is one of the property. We already discussed in the structure. Now, second point, one with lower oxidation state. Lower oxidation state means oxidation state less than +5. Such compounds less than +5, they has either PP or pH bonds. That is example H4P2O6. H4P2O6. In this case, it contains either PP bond. PP bond is present in this. So, compounds having oxidation state less than +5 has either PP or pH bond. Okay, either PP or pH bond. pH bond example, which one is having pH bond? H3PO2. Take one example. Okay, here we can see pH bond and here we can see PP bond. So those having lower oxidation state have either PP or pH bond. Now, those having +3 oxidation state. Those having +3 oxidation state. What's the difference? We can see that is phosphorus shows this proportion. Phosphorus shows this proportion. We can discuss with an example. Example H3PO3. For H3PO3 on heating, what happens? This proportion takes place. This is phosphorus acid. Orthophosphorus acid. On heating, it gives 3H3PO4. This is orthophosphoric acid and phosphine is obtained. So this proportion takes place. This proportion. Those having +3 oxidation state. Now, acids with pH bonds. With pH bonds have strong reducing properties. pH bonds have strong reducing properties. Okay. Reducing properties. Hypophosphorus acid H3PO2 having 2 pH bonds. H3PO2. Example H3PO2, it contains 2 pH. So they are strong reducing agents. They shows strong reducing property. Okay, they are a good reducing agent. And it reduces AgNO3 to metallic silver. The reaction is 4AgNO3. It reduces AgNO3 to metallic silver. Plus 2H2O plus H3PO2 gives metallic silver. 4Ag plus 4 NH3, 4HNO3. Okay. 4HNO3, 4HNO3 plus H3PO4. So, it contains 2 pH. So, it is a strong reducing agent and it reduces silver nitrate to silver. Now, next property. Next property. These pH bonds are not ionizable and they are not ionizable and give H plus ions. Okay. They are not ionizable to give H plus ion. Now, fifth property, POH bonds are ionizable. That is, hydrogen atoms attached with oxygen. POH. POH bonds are ionizable. So, these pH bonds are cause basicity, and cause basicity, they are responsible for basicity. Okay. So, those having more number of POH bond, they will be more basic. For example, H3PO3 contains 2 POH. So, they are dibasic, and H3PO4 contains 3 POH. So, they are tribasic and so on. Okay. So, these are the important compounds of oxoacids of phosphorus. These are the important compounds. So, we already discussed some oxoacids of phosphorus. Okay.